And when you're dealing with absolute value graphs, it winds up being a pretty consistent pattern. And you can do this without using a calculator, although, again, we'll review how the calculator can help you with it. But here is the basic pattern for an absolute value graph. And each of these variables kind of stands for something. The x and the y and the absolute value symbols will stay. The a, the h, and the k vary depending on a couple pieces of information. Okay, the a is the slope. This is going to shrink or stretch your graph. Okay, and it's going to shrink or stretch based on a couple things. Okay. The main thing is if it's less than 1, if the absolute value of your a value is less than 1, meaning it's a fraction between 0 and 1, okay, then your graph is going to shrink. If your value is greater than 1, okay, then it's going to stretch. Okay, there's one other thing that this a value relates, and that is whether the graph opens up or down. Okay, if a is positive, then your graph opens up. And if a is negative, then your graph opens down. Right? So that's all the information that is contained based on just the a value. Okay, so if I gave you some just real simple, and I'll come back to this page here in just a second, okay, but if I just gave you this, y is equal to the absolute value of x, here's what your graph would look like. Okay, it's just a V, okay, straight lines extending up at a 45-degree angle. Okay, now, anytime I put some number in front of this, that number is going to shrink or stretch it. Okay, so it's positive, so that means our graph is still going to open up, but it's a fraction smaller than 1, so it's going to shrink it. It's going to make it a flatter graph. And the easiest thing to do is you can just plot some points. In this particular graph here, the slope is 1, so you'll go up 1 over 1. So this original graph, and it's over 1 in each direction. So it's up 1 over 1 in each direction. Okay, this graph here, if we were to sketch it, is going to go up 1, but this time it's going to go over 2. So up 1 over 2 in each direction. And so if we were sketching this graph, I'll sketch it in red. Again, it's straight lines. They're going to pass through those points. It's still a V shape, but that would be the example of 1/2 times the absolute value of x. Hey, what if you had an equation that was absolute value, or -2 times the absolute value of x? So the negative means our graph is going to open where? Down. And our slope is 2 over 1, so now we're going to go down 2 over 1, down 2 over 1 in each direction from that vertex. Again, the vertex is always going to, for this general graph, starts at the point 0, 0. And so now we have this steep graph. It's not flat, it's not that 45-degree angle of the original equation. And it opens down, we get that from the -2, the negative part of that. Okay, are there questions on what that a value does to your graphs? Okay. Let's go back and take a look at the next part I want to talk about, the k part. Okay, this k part here is going to shift the graph up or down. Okay, so this determines the vertical shift. Okay, and so when you're looking at this vertical shift, If k is positive, it shifts up. And if k is negative, it shifts down. And it'll shift that many units, whatever the value of k is. Okay, so the part that falls outside of the absolute values is what's going to present your vertical shift. Okay, so again, let's kind of take a look at a graph that has those properties. All right, so here we have a graph y equals -3 absolute value of x plus 2. Okay? The first thing that you want to do when you're graphing these is you want to plot your vertex. The vertex originally was at 0, 0, but what's our vertical shift telling us? We have to shift it where? 2 up. So we go up 1, 2. So here's our new vertex. Okay? My suggestion when you're sketching these is to label the vertex opposite the direction that it opens. Okay, so what are we expecting this graph to open, up or down? Open down. So we're going to label it above, and so the point is 0, 2. So here's my vertex. Now I can use my slope. My slope is 3 over 1, so I'm going to go down 3, 1, 2, 3 over 1 in each direction. And that is my graph. So I use that information to sketch my graph. Okay. I'll do a second one. I'll do it on a separate set of coordinates. Okay, let's say we take a look at the following. Okay, so let's say we take y is equal to 1/2 absolute value of x minus 3. And I'll resketch it here. Okay, where's my vertex going to be shifted? Down 3. So 1, 2, 3. Here's my vertex. Is my graph opening up or down? It's opening up, so I want to label my point below it, opposite it. So 0, -3 is my vertex. My slope is 1/2. So I'm going to go up 1 over 2 in each direction. So up 1 over 2. And then just connect those. Okay. And so that's my equation, or that's my graph. I've completed the transformation. Rick, question on this? Good. All right, so that's the vertical shift. So let's come back, do the last thing, and then we'll put it all together in an example. The last thing here is H. H is the horizontal shift. Okay, now, here's the way I teach horizontal shift, because oftentimes it can cause some confusion. All right, so if you take that whole expression inside the absolute values, so the x minus h, and you set that equal to 0, your horizontal shift is going to be whatever value of x would give you 0 inside that. Okay? Usually, if it's in this form, it's the opposite of h. So if your value inside absolute value is x plus 2, your shift would be -2, 2 to the left. If your value inside the absolute value was x plus 3, or x minus 3, your shift would be the opposite of that -3, so it would be +3, so it would be 3 units to the right. Okay? The easiest thing to teach that I found is just take that entire expression inside the absolute values, set it equal to 0, and that will be your shift. And I'll explain why I teach it this way here in just this example. Okay, so let's say we take the equation y is equal to 2/3 times the absolute value of x minus 1 plus 2. Okay, so if you're looking to sketch this graph without having to use your calculator, okay, it winds up being really easy. What's your vertical shift? +2. So we go up 2. Here's your vertical shift. Okay, your horizontal shift, when you set this expression equal to 0, so if you take x minus 1 equals 0, what does x equal? 1. So that means you're shifting this 1 unit, okay, and a plus 1 or a 1 unit is to the right. So we're going to take our vertex, move it up to the right 1. Okay, is this graph opening up or down? It's a positive value in front. So it's going to open up. Okay, so here I'm going to label below. So I have the point 1, 2 is my vertex. And then when I use this slope that's written out front, my next set of points I can find move up 2 over 3. So 1, 2, 3. So I get this point. And up 2 over 3, 1, 2, 3. This point. And so when I connect these, I have my sketch. So all of that information can be found just by looking at this form of the absolute value equation. And if I ask you to label a set of points, my expectation, I'll generally ask you to label 3 points. I want the vertex, and then I want 1 point on either side of that vertex. So here I have 1, 2, 3, 4, up 1, 2, 3, 4. And here I have -2, 4 as my other point. So I am going to expect to see the points labeled properly in that case as well. Okay, the reason I teach it this way, and some of you, what you'll find in probably almost all the homework problems that you get here, your horizontal shift is usually just the opposite of this constant. So what's the opposite of -1? +1. If this had been y equals absolute value of x plus 5, okay, where's the vertex going to be on this? You have a horizontal shift of -5 and a vertical shift of. So -5, -2 would be your vertex for this graph. And so it winds up being really easy to see, and it's almost always, for what you guys are going to see this year, the opposite of this. However, there are times where this might be written in this form. Okay, and so if you're looking at it in this form, the horizontal shift isn't -5, which is what most people would expect, right? Because if your rule is you're just taking the opposite of that, then you're not going to see that, you're going to think that it's -5. But if you use the rule of take the entire expression inside absolute value and set it equal to 0, what the value of x gives you 0 in there? What value of x will give you a 0 in this expression? 5. So that is your actual horizontal shift. So you're actually shifting it 5 units to the right, down 2 units. Okay, so be careful on that. You shouldn't have to. You probably won't see this type of equation or form, but just on the off chance you do.